question 9. Finally, the last question for this test. So, we have a function right here. And the graph of the function is also given. And it is said that we have here 3 points. The point P is the intersection with the y-axis. The point R is the intersection with the x-axis. And the point Q is a local maximum. And the coordinates for this point are also given. At A, we have to find P. The point P. So the point P is intersection with the y-axis, and therefore x value is 0. And I have the function here. Five e to the power of x minus e to the power of 2x divided by e to the power of x plus 1. So I have to substitute x equals 0, and I get 5e to the power of 0 minus e to the power of 2x, which is 2 times 0, which is also 0, divided by e to the power of 0 plus 1. So e to the power of 0 is 1. Then I have here 5 times 1, which is 5, minus e to the power of 0, which is 1. And in the denominator, e to the power of 0 is again 1, plus 1. Then I left here with 4 divided by 2, which is 2. And therefore, the point P have an x coordinate of 0. Yeah, it's the intersection with the y-axis, and a y y value of 2. This is the answer to A1. Now I have to find the coordinate of R. R is intersection with the x-axis. So now I have to plug in y equal 0, because on the x-axis the height, the y value is 0. So I have the function right here, and I have to substitute f for 0. Then I get 0 equal 5e to the power of 2x minus e to the power, to the power of x minus e to the power of 2x divided by e to the power of x plus 1. So I do common denominator, but in the left hand side it is just multiplication by 0. Then I get 0 equals 5e to the power of x minus e to the power of 2x. Here I will take e to the power of x out, and I left with 5 minus e to the power of x. I can divide the equation by e to the power of x, because e to the power of x is has a positive value, and it cannot be 0, because an exponential term cannot be 0. So I can just divide by it, and I left with 0 equals 5 minus e to the power of x. And if I take e to the power of x to the other side, I left with this equation. Now I take the ln operation from both sides. Ln of e to the power of x equals ln 5. And here I apply the logarithm rule that I can move the exponent right here in multiplication with ln e, and ln e is 1. Ln is the logarithm with the natural base of the number e, so it's log from base e of e, which is 1. And then I left with x equals ln 5. So the point R has an x coordinate of ln 5 and a y coordinate of 0. This is the answer for A2. Now moving on to part B. Part B, we are asked what is the range of f. So in order to answer that, I can just look at the given function. Here it is. And the range is all the possible y values the function can get. So I see that the y values that the function can get starts here at the local maximum at the point Q, and then I get all the possible y values till minus infinity. So I can say the range is simply the y value of Q and all the y values beneath it. So from the graph, the range is all y values that are less than the y value of the point Q, which is 7. It is given 7 minus 2 square root of 6. So this is the range of the function. This is the answer to B. Now moving on to C, we have to show what is the derivative of the function f. So I will quickly write down f again. 5e to the power of x minus e to the power of 2x divided by e to the power of x plus 1. So I will differentiate the function, and the function is a rational function. It means that it has a numerator and denominator, and I can apply the quotient rule for a derivative, which means that I have to first differentiate the numerator. So I start. Maybe I do here a small reminder. So if I have an expression u divided by v, and I want to differentiate it, then I have to take the derivative of the numerator multiplied by the denominator untouched, minus the derivative of the denominator multiplied by the numerator untouched, and all of that divided by the denominator squared. So this is just a reminder for the quotient rule of differentiation. And now I'm going to apply it. So I look at the denominator and I differentiate it. So the differentiation of the function e to the power of x is e to the power of x. and 5 comes with multiplication, then it stays as is. Now I have to differentiate e to the power of 2x, so it stays the same, but I have to multiply it by 2 because the derivative of the exponent is 2. So this is the derivative of the numerator, and now I have to multiply it by the denominator without differentiating it. Now I have to take the derivative of the denominator. So the derivative of e to the power of x is e to the power of x, and the derivative of 1 is 0. So the derivative of the denominator is simply e to the power of x. And now I have to multiply by the numerator without differentiating it. And all of that should be divided by the denominator square. So now I'm going to develop this expression further. So I will get 5 e to the power of 2x plus 5 e to the power of x minus 2 e to the power of 3x minus 2 e to the power of 2x. Second term, minus 5 e to the power of 2x and plus e to the power of 3x. Yeah, so I also remind you, when we have e to the power of x times e to the power of 2x, we simply have to add the exponents. So it will be e to the power of 3x. And this is just a short reminder. Going back to developing the derivative expression, I still have the denominator here, square, and now I have minus 2 times e to the power of 3x and 1 time e to the power of 3x, so I get minus e to the power of 3x, 5 times e to the power of 2x, and minus 2 times e to the power of 2x, and minus 5 times e to the power of 2x is minus 2 e to the power of 2x. Yeah, I can simply do that. And I still have this term here with 5 e to the power of x. And I still have in the denominator e to the power of x plus 1 square. So this is the derivative, and this is exactly the term that was given in the question that we need to show that it equals to the derivative. So this is the answer to part C. Moving on to the final part, part D, I have to show that Q equals ln of square root of 6 minus 1. So Q was given, yeah, a lot of scrolling here, is the coordinate of the point Q, the local maximum point. So I can find this local maximum by equalizing the derivative to 0. And since I have here an expression for the derivative, this is what I calculated in C. If I will write the equation that this term in C equals 0, then I will get the x coordinate of the maximum point, which is exactly q. So let's do it. I say f tab f prime equals 0. Then I get 0 equals negative e to the power of 3x minus 2 e to the power of 2x plus 5 e to the power of x divided by e to the power of x plus 1 square. Let's solve this equation. So I do here a common denominator, which means that I have to multiply here by the denominator from here, but since here I have 0, it will stay 0. And in the right hand side, I left with this term. Now I will take e to the power of x out. So I left with negative e to the power of 2x. Here I left with minus 2 e to the power of x plus 5. Now I divide the equation by e to the power of x, which is non-negative, since it is an exponential term. So I left with minus e to the power of 2x minus 2e to the power of x plus 5. Now this is actually a quadratic equation. One can see that by the substitution. If I will call e to the power of x t, then I can write that then if I e to the power of 2x will be t squared, because if I take this expression and square it, I get on the right hand side t squared, and e to the power of x squared, here I apply the rule that an exponent of an exponent, one can multiply the two exponents. Yeah, so this is again a reminder. But if I go back now to my term, so I know that e to the power of 2x is t squared, so I have here negative t squared minus 2t plus 5. So it is a quadratic equation. Now I have to solve for t. So I get 2, 4, 2 squared, negative 2 squared, minus 4 times minus 1 times 5, so it's plus 20, and divided by minus 2 because it's 2 times negative 1. So I get here 2 plus or minus the square root of 24 divided by negative 2. Now I will say that 24 is like 6 times 4. I have to take the square root of 6 times 4. Now we need to show that q equals ln of the square root of 6. So I know it's something with the square root of 6. I continue here. I have 2 plus minus, and now when I have square root of two terms that comes in multiplication, I can simply write it as the square root of 6 times the square root of 4, and the square root of 4 is 2. And I left with 2 plus minus 2 times square root of 6 divided by -2. So I can take out here in the denominator 2 out. I will left with 1 plus or minus square root of 6 divided by -2, and then I can strike down 2 and 2. I still have -1 in the denominator, and therefore I get here -1 because I divided by -1, and plus minus divided by 1 stays plus or minus. But here I have two options. -1 minus the square root of 6, or -1 plus square root of 6. And this is the values for t. And t was e to the power of x. Since e to the power of x is an exponential term, it is non-negative. So this term here is definitely negative. So it is not possible. I can strike it down and say t is non-negative, or is more than that is positive. And I left just with this solution. So t equals that, but t is e to the power of x. Then again I apply ln, the ln operation, the logarithm from the with the base of the number e to both sides, and I get here that x equals ln of -1 plus the square root of 6. I already showed it before why when I apply ln to this term it will become x. So here I got actually by this is the maximum point. It's the x value of max point, because I got it from equalizing the derivative to 0, and I know from the graph that there are no other minimum or maximum points, and therefore this x value is simply the x value for the point Q. And this is the answer to D.